Welcome to our STEAM project number 7, based on the BBC Microbit, the GeekPi Microcar and the Microsoft MakeCode, in which we will drive the robot car via the infrared remote control. This course is at the introductory level. We actually assume that you don't have any prior knowledge of programming, sensors or actuators. We call this level the Scout level. My name is Peter. I am the founder of Educomondo and a certified STEAM instructor and course developer. In this project, we will learn how to work with the infrared remote control that is included with the GeekPi Microcar. Note that there is no battery included, so you will first need to insert one. In this lesson, we are going to select and install the right extension, adapt the extension and map the buttons to work with the infrared remote, and then program the microbit and the microcar to react to the infrared signal of the remote control. We have quite a job ahead of us, so let's get started. In previous lessons, we had an ultrasonic transmitter and receiver. This time we are going to work with light, infrared light, that is not visible to the human eye. Of course, you and your class are very familiar with infrared remote controls, because more than 95% of the remote controls for TVs or stereos is based on infrared signals. We cannot see the infrared light, but did you know that you can check whether the remote control sends out a signal or not by using the camera of your phone? The remote control is the transmitter of an infrared signal, which is different depending on the button you press. On the robot car, there is one infrared receiver which is connected to pin number 7. And of course, to make the microcar move, we need to activate the motors. If you are unsure about how to control the DC motors, have another look at the previous projects. Now let's go to the Microsoft MakeCode and do some serious live block programming. Here we are in our live Microsoft MakeCode environment. You know the drill. Create a new project, give it a meaningful name like Robot Car Infrared, hit the Create button, and we are in business. As always, our first step is to disable the BBC onboard LEDs, as these will create pin conflicts with our robot car. So we go to LED, select More, select LED Enable, and drag and drop it to the On Start block. Our second step is to program the motors to go forward, to go backwards, to the left, to the right, and a full stop. Now we have done this already a couple of times, so you know the drill by creating a function first. Make a function, call it forward, and we go to the pin functions, but this time we are going to use the analog write to a particular pin. An analog write to control the direction and the speed of the motor. So we do that by inserting a number between 0 and 1023 in the variable space of the function. 0 means no power at all, and 1023 means full power. So we are going to copy the analog write command a couple of times. And we remember that it is pin number 13, pin number 14, pin number 15, and pin number 16. To move forward, we have to initiate pins 14 and 16, and the others will be put to 0. So you can use the slider, or you can simply type in a value. So that is going to initiate, it's going to power up the pins 14 and 16 to make the robot car move forward. Now I will do the opposite. I copy and paste the function and rename it to backward. And of course, this means that pins number 13 and 15 need to be initiated, need to be powered, and 14 and 16 to 0. Next, I'm going to program the right turn. Rename this to right. Pin number 13 will be set to 0. Pin number 14 will be set to 1023, so full power. Pin 15 will be set to 0. And pin 16, I am going to set pin 16 to half of the value of 1023, which is almost like 511. What will this do? This will make the turn to the right a lot smoother than with the digital write commands. Next is left, so pretty much the same. So for the left function, left, I'm going to set pin number 13 to 0. Pin number 14 to 511, pin 15 to 0, and pin 16 to 1023. And now the only one that still remains is the easiest one, which is the full stop. And that will be achieved by setting all the pins to 0. That's it for the motors. Now it's time to go and look for some extensions. The third step in our programming is to use the OLED display to show which button was pressed and what is the meaning of that button. For instance, forward or left or backwards. Go to extensions, and in the search bar I'm typing OLED 12864, and we are going to select the I2C version. And as you remember, to initiate the OLED, we first have to drop the initiation into the on start block. That's it. We'll leave it for the moment. The fourth and final step is to make sure that the infrared signals transmitted from the remote control and captured by the infrared receiver on pin number 7, that those signals are understood and correctly interpreted by the microcontroller. To achieve that, we need to install another extension. So this time I'm typing infrared remote, Unfortunately, as you see that there are no extensions that will work with the specific remote control that comes with the Geek Pi microcar in the box. But the extension from MakerBit and Key Studio, that one is based on the NEC protocol and should work with most of the infrared remote controls. So let's give it a try and we will install this extension. And here it already appears in my list. Of course, this library was specifically written for the Key Studio Remote, and you can see from the image that it is quite different from the one that we have. The only way to make this work was for me to look for similar keys on both remotes. And similar keys mean the keys that transmit the same signal. So once we have the same signal identified, we can link that to a command or an action. And that is exactly what I did. So here you can see the mapping of those keys between both remote controls. To make everything work, the first thing we need to do is to tell the program that the infrared receiver is linked to pin number 7. And we do that by dragging and dropping this connect infrared receiver function in the onStart function, and we change P0 to P7. And we are not going to use Decode Key Studio, but we use the NEC standard or protocol. Now that we know what the keys are, we can start inserting them in other functions from the extension. So we are going to select a function that is going to control the actions we want when a button on the remote is pressed. And actually we want two things to happen. We want the motors to switch on and we want the display to show the direction. So under infrared receiver, I am going to select on infrared button, which will create a function that will wait for a push button and then something will happen. So if I do infrared button 1 and it is pressed, the first thing that I want is to clear everything. So I'm going to use clear, but I'm going to use the clear from the OLED. So this clear, not the clear from the basic, the clear from the OLED. That will clean my OLED display so that you start with a clean, nice screen. Next is I'm going to call a function. And the first function is, of course, forward. That's the easiest one. I'm going to pause for a moment. And let's put it to 500, so half a second. And I want to first show a number. I want the function to show a number on the OLED at position 0, 0. And here I don't want number 12, but I want the infrared button variable. So this is going to send the signal of the infrared button and display it on the OLED. Now that's just a number because I link a number with a particular action. I'm going also to include a string. And that string will be on the next line. So y equals 1. And here I'm going to type a meaningful string indicating what the action is. So what happens here when I push button number 1, it's going to clean and clear my OLED. The car is going to go forward, and I'm going to show a number, and it's also going to show what is the direction. So I have 2 control points actually. And next, the left, the right, the back, the stop, all of those will follow the same structure as the forward and backward command. So I'm going to copy paste, and if button number 5 is pressed, then it's going to call the function to the right. So call right. Okay, and I want to remove call forward. Okay, and that will be the same. It's going to clear my OLED. It's going to move the car to the right, and I need to change this text feedback to right. Copy paste for the left function, for instance, and that's going to be my button number 4. Function to the left, call left. And change this value to left. Let me just do the full stop. And the full stop is achieved by pressing the OK button, which is not going to be the OK button on the remote control that we have. And I'm going to call the function stop. And do it like this. That's it for the programming part. Let's download and check whether it works. Once the download is completed, then you can disconnect the USB cable and switch on the robot car. Put it somewhere on a flat surface and now point the remote to the car and push the different buttons. If all is well, the car is now fully controlled by you behind the remote. Here are some ideas of additional programming that you can do with this project. You can map some other buttons on the remote and link these to other functions, for instance, making a sound or switching on the LEDs. Ask your class to put an object between the remote transmitter and the receiver and let them observe what happens. Ask them why this is happening and what is the explanation. Give your class the challenge to gradually increase the speed of the motors. It is possible, but it requires some good thinking and experimenting with the other functions. That's it for project number 7, in which we were able to control the microcar to drive around nicely, obeying the order from the remote control. In our next project, project number 8, we are going to make some nice combinations of what we have seen so far in this series. Bye bye for now.